Related rate problem is about street light. A street light is mounted at the top of a 15 feet tall pole. A man 6 feet tall walks away from the pole with a speed of 5 feet per second along a straight path. How fast is the tip of his shadow moving when he is 40 feet from the pole? So first we draw a pole. So this is a pole that is vertical. So this is a pole. So the pole is 15 feet tall, and then a man 6 feet tall walks away from the pole. So I assume that the man is moving to the right hand side. So here is the man. So it's 6 feet tall. We draw another vertical line. So this man is a 6 feet tall. So we have a man, and then we have a pole. So there is a distance between the pole and the man, right? So this is the distance, and then we keep reading. How fast is the tip of his shadow moving when he is 40 feet from the pole? So that is a street light. And then what about the shadow? So the shadow, the light is going to this direction, right? The light is going to this direction, so that casts a shadow like right here, and then this is the tip. So the shadow, let me use a different color for that, and then this is the length of the shadow. So this is the tip of the shadow, and then that is everything we need, right? So let's read the problem one more time, and then we define the variable. A 6 feet tall man, so this is a 6 feet tall man, walks away from the pole. So from here to here, right? This direction, this is the bottom of the pole, walks away from the pole at 5 feet per second. So now this is how I define the length. So I call this x, and then I say that x is the distance between the pole. X is the distance from the pole to the man. And then I call this a y. Y is the distance from the man to the tip of his shadow. Alright, so now we got x and y, and then there is a 5 feet per second. So that is the rate of change of x with respect to time. And then by the way, t is the time in second. So the dx dt, the rate of change of x with respect to t is 5 feet per second. So 5 feet per second. Since we are going to do implicit differentiation, you cannot use the word rate. So for rate, you have to use dx dt. And then what else? How fast is the tip of his shadow moving when he is 40 feet away, when he is 40 feet from the pole? Okay, here is how we are going to do it. In this problem, it's a little bit different than the other problem. We have to use a similar triangle. So here is the similar triangle. Let me move up a little bit. We have a big triangle and a small triangle. So here is a big triangle. This big triangle, I have a 15 feet, and then I have a man right here, right? So the height is 15, the base is x plus y, and then I have a small triangle, this one. So let's draw a small triangle right here. So this is my small triangle. The height is the height of the man, that is 6 feet tall, and then the base is y. How do you set up equation for a similar triangle? So here is how we do it. First, I am going to compare the height and the height. So this is a bigger triangle divided by a smaller triangle, and then I set that equals to compare the two base. So since the top, the numerator, stands for the information of the big triangle, so we have the height. What about the base? The base is x plus y, and then the small triangle, the base is just y. We will need this in a minute. What is the question asking? Now, this is where you have to pay attention. This problem is a little bit different than the other problem. Let's read the problem again. How fast is the tip of his shadow moving when he is 40 feet from the pole? The question is asking this. The tip of the shadow, so that is x plus y. X plus y. They are asking for the rate of change of this dx dt. The rate of change of the tip. What is that equals to when x is equals to 40? What is 40 stands for? 40 is when he is 40 feet from the pole, right? The distance between the pole and the man. Now, how do we differentiate this? This is the derivative with respect to t of x and y. So this one we will have to do a substitution. So let's start the d dt right here. So the d dt, we are trying to find out this, right? X plus y. But I want to put this in one variable. Can we? The answer is yes. So to do so, we have to use this. I have to write this in terms of x. So this one, how do we get out of the fraction? We use cross multiplication. 15 times y equals to 6 times x plus y. And then we have 15y equals to 6x plus 6y. Subtract 6y on both sides. 15 minus 6 is equals to 9. That is equals to 6x. And then y is equals to 6x divided by 9. That is equals to 2/3 of x. And then you plug in this y into here. So you have d dt of what? Of x plus 2/3 of x. 1 plus 2/3 is 5/3. So that is d dt. We have 5 divided by 3x, and then we use implicit. So the variable is x, but d dt, what is d dt? d dt means we treat t as a variable, all right? So that means we do derivative anyway. So the question that you have to answer me is, what is the derivative of 5/3x? The answer is 5/3, right? So because 5/3x is linear, the slope is 5/3. Using implicit differentiation, this is supposed to be with respect to t. All right, so with respect to t, then we have to add a dx dt in there. And then what is dx dt? Dx dt is 40, right? So that is oh, actually dx dt is not 40. Dx dt, we got dx dt right there, is 5. I was doing this too fast. So 5/3, the dx dt 5, where is the 5? 5, you go back to the notes, is 5 feet per second here. With a speed of 5 feet per second. A man walks away from the pole with a speed of 5 feet per second. This is the rate of change of x. So that is where you have to plug in. So that is equals to 5. That is given in the problem. So you have 25/3 feet per second. That is the answer that we are looking for. And you are right, 40, we don't need to use the 40 at all in this problem. So that's why I said this problem is a little bit different than the rest of the problems. All right, I see you in the next one.